Howdy folks. Noticed several people were struggling with the chain rule, so I thought maybe I'd do a video, go over a couple of the problems off the worksheet, and see if it might help a little bit. What I'm going to do is on the worksheet that says derivative rules number 5, chain rule, on the front I'm going to do question number 2, then I'm going to do another example without using all the crazy stuff here, but I do want to go over an example that includes all this additional stuff down here, the technical process, just so that you can see how it works in case that can help you. But ultimately your goal is to be able to do the chain rule without having to go through the entire process. But you got to understand what the process or what the chain rule, what's happening behind the chain rule while you're doing it. So let's see. We've got y equals 3 times x squared minus 5 to the 7th power. Okay? So, and we want the derivative. We want dy dx. All right, so we're looking for dy dx is ultimately what we want to get. Now, on the worksheet here, it says, the next thing right under this, it says u equals. Now, what is u? Well, u is a substituting variable. Okay? We've got two functions going on here. One of them is the outside function, which is 3x to the 7th power. The other function is the inside function, meaning the inside of the parentheses, or inside of the x, is x squared minus 5. So this is our inside function, this is our outside function. Okay? And the chain rule allows us to be able to find the derivative of a composition function, where one function is inside of the variable for the other function. So we're going to call the inside function u, because it's going to make things a little bit easier to understand. So we're going to say x squared, u is equal to x squared minus 5. Now, the next part says y of u, meaning the output y variable as a function of the input variable u. Okay? So what we're doing is this, is we're going to rewrite y, but instead of making y as a function of x, we're going to replace x squared minus 5. We're going to substitute in the letter u. So if we take this out and put u in there, it's 3u to the 7th power. So 3u to the 7th power. Okay? So far so good? Now, the next thing on the worksheet says, what is dy du? And anytime you see that, what you're looking at is this. You want the derivative of an output variable with respect to an input variable. Okay? Now, if we look at this function here, the output is u and the input is x. But we're looking for something that has an output of y with an input of u. That's over here. Output of y, input of u. And we want the derivative. And all we have to do is apply the power rule. So, power rule, 7 times 3, 21. U, reduce the power by 1, goes down to 6. So the derivative, the dy du is 21 u to the 6th power. Next line down says we want du dx. Now that is a situation where u is the output variable and x is the input variable. Output, input. So we want the derivative of this, basically. So we apply the power rule to this function. 2 comes up front, that's 2x, and the power reduces to 1, so it's just the first power is just 2x. And the constant, the derivative of any constant is 0, because the rate at which a constant changes is 0, because constants don't change. Why? Because they're constant. They don't change at all, so no rate of change. So it's just 2x. So we've got dy du, we've got du dx. Now here's the interesting thing. When I'm going to write these over here, okay, and I want to do something interesting here. Well, to me it's interesting, maybe it's not interesting to you, but I think if you notice what happens here, you'll find it interesting. That if we multiply these two derivatives by each other, If we multiply this times this, what happens is the du's are going to cancel, okay? Because we got a du in the numerator, a du in the denominator, and so then they cancel, and all we have left is just dy over dx, because these cancel out. And all we had to do to get, and that's what we're looking for, right? dy dx. And all we had to do to get dy dx is multiply these two derivatives times each other. The derivative of the inside function times the derivative of the outside function. So dy dx is equal to the derivative of the inside function, 2x, and it doesn't matter which order you put them in, it's commutative, so it doesn't matter. So the derivative of the inside function times the derivative of the outside function, but what I'm going to do before I write it over here is I'm going to change this u, I'm going to substitute back in for the u, I'm going to put the x squared minus 5 back. So then this is going to become 21 times x squared minus 5 to the 6th power. And now I'm going to put that over here, times 21 times x squared minus 5 to the 6th power. Okay? And so what you could have done, instead of going through all of this is good for understanding, but it takes too much time, especially on the AP exam. They don't give you enough time to write out all this stuff. I mean, I guess if you were fast and you had to, it'd be fine. But generally what people just do, or at least what I do, is you look at the question, and if you want the derivative, you just ignore everything on the outside. Just take the derivative of the inside, which is 2x. And then multiply it by the derivative of the outside. But imagine that this x squared minus 5 is just an x, or just a letter. Okay? So take the derivative, apply the power rule as if this isn't even here, as if it's just a letter. 7 times 3, 21. This reduces to the 6th power. But what happens is the inside, whatever this is right here, it just stays as is. It does not change. It just stays as x squared minus 5. And what I want to do now is I'm going to make up a problem, and I'm not going to do all this. I'm just going to make up the problem and write the derivative with using the chain rule. Okay? And what I would encourage you to do is get a piece of paper, pause the video in just a second after I write this problem up here. Pause the video, work it out for yourself, then hit play again and see if you got it right. Okay, so we're going to say that y is equal to, let's say, 3 times 18x to the 3rd minus 9, well, let's make it 91x plus 7, just for fun. And we'll put this to the, I don't know, we'll make it to the 8th power, okay? It doesn't really matter. As long as we know how to do basic multiplication and the power rule, we're good. So go ahead and pause it now, and then come back in a minute after you've done it, and we'll work it out. Okay, so if I want the derivative of this, meaning I want the change in y as the x in here changes, so dy dx, the derivative is going to be the derivative of the inside, ignore all this stuff out here, just inside the parentheses, the derivative, 3 times 18 is 54, x to the 2nd power, reduce the power by 1, okay, minus 91, x goes away, derivative of the 7 is 0, so it's just gone. And I want that's got to be inside of parentheses because it's a binomial and I'm about to multiply. If I'm going to multiply a binomial, I got to separate the binomial with the parentheses. Times, now I'm going to take the derivative of with the 8 power with the 3 coefficient, and I'm going to pretend that this is just a variable, one letter, just an x. 8 times 3, 24. Now I'm going to put this in unchanged. It's going to stay exactly as it is. 18x to the 3rd minus 91x plus 7. And now my power 8 reduces to 7. And there is the derivative of that using the chain rule. And that's it. Okay? I'll do a couple more videos where I do some of the problems on the back of this worksheet. But that's it for now.